Hello friends, welcome to True Event Academy. In the last lecture, we have started the discussion on the kinematics and two dimension. So in this particular lecture, we will start discussing problems on the kinematics in two dimensions. So let's start our discussion. So what is given in the question is that a particle moves along a curve given by x is equal to t cube plus 1, y is equal to t square, and z is equal to 2t plus 5. Okay, where t is the time. Find the components of the velocity and acceleration at time t is equal to 1 in the direction given by um, I cap plus j cap plus 3k cap. Okay, so we have to find the components of velocity and acceleration in this particular direction. Okay, so let us consider this direction as I cap plus j cap plus 3k cap. Okay, let us consider the direction of the velocity as this one. Okay, so we have to find the component of this velocity along this particular direction. Okay, so what we will do, we will first find the unit vector along this particular direction. So this is equal to I cap plus j cap plus 3k cap upon 1 plus 1 plus 3 square. Okay, so this is equal to n cap is sorry n cap is equal to I cap plus j cap plus 3k cap upon 11 root under. Okay, so for finding the velocity along this particular direction, let us consider the component as v1. Okay, so v1 is in the direction of this I cap plus j cap plus 3k cap. So v1 vector is equal to v into n cap. Okay, so this will be the component of velocity along the direction of I cap plus j cap plus 3k cap. Okay. Similarly, acceleration along this direction. Suppose the acceleration along this direction is a1. A1 vector. So a1 is equal to a vector dot n cap. Okay. So let us find the position vector. So the position vector is given by x I cap plus y j cap plus z k cap. Okay. So this is equal to t cube plus 1 I cap plus t square j cap plus 2t plus 5 k cap. Okay, this is the position vector. So the velocity is given by dr upon dt. The velocity is given by, so this is equal to 3t square I cap plus 2t j cap plus 2k cap. Okay, so velocity at t is equal to 1 is given by 3 I cap plus 2 j cap plus 2k cap. Okay, so this is the velocity at t is equal to 1. Now let us find the acceleration. Acceleration is equal to dv upon dt. So this is equal to, let us differentiate this equation with respect to 2. So this is 60 I plus 2 j cap. Okay, so acceleration at t is equal to 1 is 6 I cap plus 2 j cap. Okay, so this is velocity and this is acceleration. So let us find the velocity and component of velocity and acceleration in direction of I cap plus j cap plus 3k cap. So the unit vector is our unit vector is I cap plus j cap plus 3k cap upon root under 11. Okay, so let us find the component of velocity. Okay, so component of v in direction of I cap plus j cap plus 3k cap is equal to v vector is 3 I cap plus 2 j cap plus 2k cap into I cap plus j cap plus 3k cap upon root under 11. This is equal to 3 into 1 plus 2 into 1 plus 2 into 3 upon root under 11. This is equal to 11 upon root under 11. This is root under 11. Now the component of acceleration in direction of I cap plus j cap plus 3k cap. ये कैसे निकालोगे? So acceleration vector into, this is given by, so this is component of acceleration is given by acceleration vector is this 6 I cap plus 2 j cap upon into n cap. N cap is I cap plus j cap plus 3k cap upon root under 11. So this is equal to 6 into 1 plus 2 into 1. 11. This is 8 upon root under 11. Okay. So the component of velocity is root under 11 and component of acceleration is 8 upon root under 11 along the direction of I cap plus j cap plus 3k cap at time is equal to 1. Okay. Let us solve question number 2. So what is given in question number 2? The particle moves along a curve whose parametric equations are given by x is equal to et, e minus t, y is equal to a cos 3t and z is equal to b sin 3t. So the position vector is given as r is equal to x I cap plus y j cap plus z k cap. Okay, so r vector is equal to e to the power minus t I cap plus a cos 3t j cap plus z is equal to b sin 3t k cap. Okay, so now velocity is given by dr upon dt. So this is equal to minus e to the power minus t I cap minus 3a sin 3t j cap plus 3b cos 3t k cap. This is the velocity. Okay, and acceleration is given by dv upon dt. So this is equal to e to the power minus t into I cap minus 9a cos 3t j cap minus 9b sin 3t k cap. Okay, so this is the velocity and acceleration at time t. Okay, this is part 1. Second part, find the magnitude of velocity and acceleration at t is equal to 0. So the velocity at t is equal to 0. So let us put t is equal to 0 in this. So this is equal to t is equal to 0. This is minus 1 I cap. Okay, minus I cap. Na? T is equal to 0. E to the power 0 is 1 and this is minus. Okay, this is minus I. This will be 0 and this will be 3b plus 3b k cap. Okay, so the magnitude of velocity will be 1 plus 9b square root under. Okay, now acceleration at t is equal to 0. So let us put t is equal to 0 in this. So this is equal to I cap minus 9a j cap and this will be 0. So the magnitude of acceleration will be 1 plus 9 square a square under root. Okay, this is the answer of second part. Now let us discuss question number 3. The acceleration of a particle at any time t is given by a is equal to 12 cos 2t I cap minus 8 sin 2t j cap plus 16t k cap. If the velocity and displacement are 0 at t is equal to 0, find the velocity and displacement at any time t. So this is the acceleration. So this is equal to dv upon dt. So let us integrate this with respect to t. So dv v is equal to integrate of dv is equal to the integration of this with respect to 2. So this is 6 sin 2t I cap and this is plus 4 cos 2t j cap and this is plus 16t square upon 2. This is 8t square k cap plus constant of integration. Let us take this as c1. So velocity at t is equal to 0 is equal to 0. Okay, so this is equal to, let us put 2 is equal to 0. So this is 0, this is 0. So we have 4 j cap plus c1 is equal to 0. This means c1 is equal to 4 j cap. Okay, so let us put c1 is equal to 4 in this. So we have v is equal to 6 sin 2t I cap plus c1 is equal to 4 j cap. So if we put c1 is equal to 4 j cap, this will gets combined to j cap. So this is 4 times of cos 2t minus 4 j cap. Sorry, cos 2t minus 1, no? Minus 1 plus 8t square j cap. Okay, so this is the acceleration. This is the velocity. Velocity at time t. Now let us find the displacement. If the velocity and displacement at time t is equal to 0 is 0, find the velocity and displacement. So now let us find the displacement. So we have this velocity is equal to, so we can write v is equal to ds upon dt. So this is equal to 6 sine 2t I cap plus 4 times of cos 2t minus 1 j cap plus 8t square k cap plus c2. So let us integrate this with respect to t. So we have s is equal to minus 3 cos 2t I cap. This will be equal to 2 sine 2t j cap plus 8t cube upon 3 plus c3. Okay, now displacement at t is equal to 0 is equal to 0. So let us put 0 in this, minus 3 I cap. This is 0. And this will also be k cap will also be 0. This is k cap plus c3. Sorry, c2. This is c2, no? K cap plus c2. Okay. So c2, this means c2 is equal to 3 I cap. So we can put, so we have to put c2 is equal to 3 I cap. So let us put this. C2 is 3 I cap. 3 I cap. So we have S is equal to 3 1 minus cos 2t I cap plus 2 sin 2t j cap plus 8t cube upon 3 j cap. Okay. So this is the displacement. So this is the velocity at time t and this is the displacement at time t. Okay. Let us discuss question number 4. What is given in the question? A point moves in a plane, its velocity parallel to the axis of x and y being u plus ey and v plus ex respectively. Show that moves in a conic section. Okay, so velocity parallel to axis of x. Okay, this is equal to dx upon dt. This is equal to u plus ey, and velocity parallel to axis of y is equal to dy upon dt. This is equal to v plus ex. This is equation 1 and this is equation 2. So let us divide equation 1 by equation 2. So we have dx upon dy is equal to u plus ey upon v plus ex. So we have v into dx plus ex into dx is equal to u into dy plus ey into dy. Let us integrate both sides. This will be constant of integration. Okay. So we have vx plus ex square upon 2 is equal to uy plus ey square upon 2 plus c. So we have e of e by 2 x square minus y square plus vx minus uy minus c is equal to 0. Okay, so ex square minus y square plus 2vx minus 2uy minus 2c is equal to 0. So this is a general second degree equation in x and y. And what we call this general second degree equation in x and y? A conic section. Conic section. Okay, so this expression represents a conic section. So what is being asked in the question is that prove a point moves in a plane. Its velocity is parallel to the axis of x and y being u plus ey and v plus ex respectively. Then show that it moves in a conic section. Okay, let us discuss question number 5. A particle is moving with a constant velocity parallel to the axis of y and a velocity proportional to y parallel to the x-axis. So similar to last question. Okay, so let us write down velocity parallel to axis of y, and what is the velocity parallel to axis of x. Okay, so the velocity parallel to axis of y is constant, so dy upon dt is a constant. Let us consider this as lambda. And velocity parallel to axis of x, so dx upon dt, the velocity proportional to y parallel to the x-axis is proportional to y. So let us consider this as dx upon dt is equal to mu into y. This is equation 1 and this is equation 2. So let us divide equation 1 upon equation 2. So we have dy upon dx is equal to lambda upon mu of y. So let us cross multiply. The mu y dy is equal to lambda dx. So let us integrate this. So mu y square upon 2 is equal to lambda into x. So we have mu y square is equal to 2 lambda into x. So y square is equal to 2 lambda upon mu into x. There will be a constant of integration also plus c. Okay, plus this will be 2c. Sorry. So this will be 2c and this is 2c upon mu. So y square is equal to kx plus c dash. Okay, where a is equal to 2 lambda upon mu and c dash is equal to 2c upon mu. Okay, so this represents a equation of parabola. Okay, so this means it will describe a parabola. So let us discuss question number 6. How we can solve this? Prove that the angular acceleration of the direction of a motion of a point moving in a plane is given by this particular expression. Okay, so we have the angular acceleration as d2 theta upon dt square. This is the angular acceleration and rho is the radius of curvature. So let us draw this. So we have let us draw a tangent at a point P. Okay, so at a point P we have drawn a tangent. So let us consider the angle as psi and we have this as rho as the radius of curvature. Okay, so let us take a elemental distance ds. Okay, so let us take the elemental distance as ds at a distance of s from a particular point. So we have the radius of curvature as ds upon d psi. Okay, so we have the angular acceleration alpha is equal to d2 psi upon dt square is the angular acceleration. So let us find first d psi upon dt. Okay, so this can be written as d psi upon ds into ds upon dt. We can write this as and so d psi upon ds is equal to 1 upon rho. This we can write 1 upon rho into ds upon dt is velocity. So v. Now let us differentiate this once more. So we have d2 psi upon dt square is equal to d of dt of v upon rho. This is equal to 1 upon rho dv upon dt. Okay, plus v into d of dt of 1 upon rho. This is equal to d2 psi upon dt square is equal to 1 upon rho into dv upon ds into ds upon dt plus v upon v into minus 1 by rho square into d rho upon dt. Okay, so this we can write this as, so ds upon dt is v, so we can write v upon rho into dv upon ds minus v upon rho square into d rho upon ds. So we can write this as d rho upon dt, d rho upon ds into ds upon dt. So this is again v, ds upon dt is v. So we can this will be equal to v. So v square upon rho square. This is alpha. Alpha is the angular acceleration. So let us further simplify this. So we have alpha is equal to v upon rho into dv upon ds minus v upon rho into d rho upon ds into and ds upon dt is v. So let us combine this. So we have alpha is equal to v upon rho dv upon ds minus v square upon rho into d rho upon ds. So this is the angular acceleration. Angular acceleration. Okay, of the direction of motion of a point. Motion of a point moving in plane. Okay, let us discuss question number 7. So how we can solve question number 7? A particle describes a parabola with uniform speed so that its angular velocity about focus varies inversely as sp 3 upon 2. So this question is a case of a Pradal equation. pedal equation. This we will study in chapter of central orbits. Okay, so what we have to remember here is that in case of parabola, the relation between small p and r is given by p square is equal to ar, where small p is the small p is the pedal length. Pedal length. Okay, so let us draw this graphically. Okay, so let us understand this graphically. So let us draw a parabola like this. Now, what we have to do is that let us consider this as a focus. Okay, what we will do is that we will drop a perpendicular on a tangent. Okay, so this is our tangent. Tangent is drawn at point P. Okay, and let us consider this as focus. So this is our radius vector. Okay, and this SA, let us name this as SA. We have dropped a perpendicular from point S on this tangent. Okay, so this AS is small p. This is small p. So this is small p is the length of pedal. Length of, okay, and this PS, what the SP is this distance R. SP is equal to, sorry, SP is equal to a small r. Okay, now what we will do is that we will extend this. So let us extend this. So this is our radial direction, and this is our perpendicular, that is transverse direction, So let us take this angle as phi. So this will also be phi. Okay, so we have velocity. Let us take this as a velocity along the tangential direction as v. So the velocity along phi will be v. Velocity along the radial direction is vr, and velocity along the transverse direction is v phi. Okay, so what we have to find is that we have to find the angular velocity. Draw a circle like this, taking r as the radius. Okay, so if we look into this circle, so the angular velocity will be, so the velocity along perpendicular to r will be v phi. So angular velocity will be v phi upon small r. Okay, and we have the velocity as this. So v is velocity along the tangential direction. Along the radial direction we have vr, and along the transverse direction we have v phi. Okay, so this is phi. So vr will be v cos phi, and v phi will be v sin phi. Okay, so this is equal to v sin phi upon r. Okay, so the angular velocity will be v sin phi upon r. So this is equal to v into r sin phi, and let us multiply this at the denominator also. This will be r square, and r sin phi we will have p, small p. So this distance as. Okay, so let us look into this triangle. So in this, sorry, let us look into this triangle. So we have this like this. This is r, this is phi. So this will be r sin phi. This is equal to small p. So this will be equal to Vp upon r square. So angular velocity is Vp upon r square. And we have small p is equal to AR. Small p square is equal to AR. This means p is equal to AR ka root under. So let us put here. So V into root under AR upon r square. So this is equal to V root under A into R1 upon 2 upon r square. This is V root under A upon R3 upon 2. So angular velocity is proportional to 1 upon R3 upon 2. This means angular velocity is proportional to 1 upon, and what is this r? R is SP. R is equal to SP. So 1 upon SP ka whole 3 upon. Okay, so this is being asked in the question is that angular velocity varies inversely with sp 3 upon 2. Okay, let us discuss question number 8. So how we can solve question number 8? Prove that the angular velocity of a projectile about the focus of its path varies inversely as its distance from the focus. Okay, so what is the concept of the projectile is that let us consider a projectile like this and we have a directrix. Okay, so that and let us consider this as a focus and let us take this point as P. So the distance of this point from S is same as the distance of this point from the directrix. So this distance is equal to this distance. So let us take this as M. So we have SP is equal to MP. That is distance of point P from S is equal to distance of point P from directrix. Also, the velocity attained by the projectile through this path at point P. So let us consider the velocity at point B as V. Okay, so this value of this V is same as velocity attained by the particle if it is allowed to have a free fall from point M. Okay, suppose the point is allowed, suppose the particle is allowed to have a free fall from this point M. So it will attain some velocity at point P. So let us consider this velocity as V dash. So V dash is equal to V, as simple as that. So let us take this distance as MP. So V dash is equal to 2G of MP root under. Okay, so V dash is equal to 2G of MP. So this distance is R. So this distance will also be R. So V dash is equal to 2G into R. So we have the velocity attained by the projectile through this path, through this trajectory is V. So we have V dash is equal to V. So this is equal to root under 2G R. Okay. So now we have the angular velocity is equal to Vp upon R square. Okay. And this we can write as and P square is equal to AR root under. This we can write as P is equal to root under AR. So this will be equal to V into root under AR upon R square. And V we have this one, root under 2GR. So root under 2GR into root under AR upon R square. So this is equal to 2GA root under into R upon R square. So we have angular velocity is equal to 2GA root under upon R. This means angular velocity varies inversely with the radius vector. Okay. So inversely as its distance from the focus. So distance from the focus is R. So angular velocity is varies inversely with distance from the focus. Okay. So we will discuss further questions in next particular lecture. Thank you.